Hey everyone, welcome to Math 103. We're working on section 2.2 today on simplifying variable expressions. So we've got some properties we're going to be using to do the simplifying. So I'm going to start with the commutative properties. The commutative properties are one way that order doesn't matter when we're talking about addition and multiplication. So as you can see with addition, a plus b equals b plus a. So for example, if we add 2 and 8 together, we get the same result as if we add 8 and 2 together. And the same thing for multiplication. If we multiply negative 3 times 4, we get negative 12. And if we reverse the order and multiply 4 times negative 3, we still get negative 12. Another way that order doesn't matter is with the associative property. So in this case, a plus b in parentheses plus c equals a plus b plus c in parentheses. So with some real numbers in there, what this means is if we add together 2 and 5 first, and then add 8, we get the same result as if we add 5 plus 8 together first, and then add 2. And so we have the same idea with multiplication. We can multiply a times b first, and then multiply it by c, or we can multiply b and c together first, and then multiply it by a. So with some real numbers, we got 2 times 4 first here in parentheses, that gives us 8, and then 8 times 3 gives us 24. We get the same result if we multiply 4 times 3 first, get 12, and then multiply by 2. We still get 24. So two different ways that order does not matter. Now some additional properties we have here. We've got the inverse properties. These are some of the most important properties when we get down to solving equations. So if we add any number and its inverse, we get 0. So 5 plus its inverse negative 5 gives us 0. And another very important inverse properties is any number times its reciprocal. If we get that, we multiply any whole number by the fraction, we multiply the whole number by the numerator, so we get a over a, and that equals 1. So for example, 8 times 1/8 gives us 1. So any number times its reciprocal gives us 1. And that's something we'll be using all the time to solve equations. A few other remaining properties. We've got the addition property of 0. If we take any number and add 0 to it, it doesn't change the value. We're right back to a. And the multiplication property of 1. Any number times 1 is itself. Now that brings us to your turn number 1, so just a reminder, go ahead and stop the video if you need some time to work on these. And your turn number 2 as well. That one we're going to be determining which properties of real numbers are being used. So here's an example of a calculation. Now go back through these properties and see if you can identify which property is being used. Your turn number 1, we're going to find the reciprocal of a, so negative 2. So I'm just going to use that to indicate reciprocal. Not a real math term, I just made it up. So negative 2, we need the reciprocal of this. So keep in mind you can always take a number and write it over 1. Now to find the reciprocal, we're going to flip that fraction over to get negative 1/2. The sign stays with it. So if it's negative, the reciprocal is going to be negative. Now the second one, we're starting off with a fraction. So we'll take that fraction and flip it over to get 8 over 1, which you can just write as 8. So 8 is the reciprocal of 1/8. Now, next up, we're going to determine which properties of real numbers are being used. So for part A, You have 2/3 times 3/2. So this is a number times its reciprocal. We do that, we get 1. So that is the inverse property of multiplication. Next up, part B. Right, 2 plus 5 plus -3, and that equals 2 plus 5 plus -3. So all we're doing here is we're changing which numbers we group together. Here 2 and 5 are grouped first, here 5 and -3 are grouped first. So that is the associative property of addition. C, 2 plus 8 equals 8 plus 2. Switching the order of addition is the commutative property of addition. D, 4 times 1 equals 4. Any number times itself, any number times 1 gives itself. All right, so that's known by a couple different names. Originally it was called the identity property because the number retains its identity. But now we're calling this a multiplication property of 1. A little more descriptive term than identity property. X plus 0 equals x. So this is the other version of the identity property known as the addition property of 0. And F, 3 times 8 times 2 equals 3 times 8 times 2. The one where we just change where the parentheses are, that is the associative property of multiplication. So make sure you can identify which property is being used. Next up is the distributive property. This may be the single most important property in algebra because it comes up so often. So the distributive property tells us, well, what happens when we take a number or a variable, or some collection of them, and multiply them by something in parentheses. So here's an example. Okay. And I'm going to pick the middle one on your sheet, 3x plus 6. So what we're doing is we're taking this expression here, 5x, and we're going to multiply it by this entire expression, 3x plus 6. So if we're going to do this, we have to multiply 5x by the first term and the second term. The terms being the things that are separated by addition or subtraction. So 5x times 3x plus 5x times 6. And in later sections, we're going to figure out what that all equals. But for right now, you need to know that we multiply the term on the outside by every term on the inside. Now let's compare distribution with order of operations when we're evaluating 4 times 2 plus 5. So on the left, I'm going to do distribution. I'm going to distribute the 4 into here. So I'm going to multiply 4 times 2 and 4 times 5. And always keep the operation you see in the middle. So that would be the first step of distribution. But if we're doing order of operations, we start by evaluating inside the parentheses. So that is 4 times 7. Continuing on here, we get 8 plus 20, or 28. And over here, 4 times 7 is 28. So whether you do distribution or you follow order of operations, you get the same result. Here's an example. You're going to use the distributive property to write 3 times 4 plus x plus y. Now what we're going to do is distribute in and then remove the parentheses. It's called clearing the parentheses. And it's an essential step in the simplification process of expressions. So I'm going to multiply 3 times 4. And generally, you don't have to write this step. But I am doing it for demonstration purposes. All right, so multiply 3 by all 3 terms. Notice we have 2 addition signs here. That means we have 1, 2, 3 terms. So that means we're going to have 3 multiplications to do. So we get 12 plus 3x plus 3y. Your term number 3. Use the distributive property to rewrite those 2 expressions. Now the only difference between part A and the example is I put the number to the right instead of to the left. Doesn't matter at all. Works exactly the same way. We're still going to take this number and multiply it by all 3 terms on the inside. So 3 times 4 gives us 12. 3 times x is 3x. 3 times y is 3y. Second one, we now have 3 different signs, 2 additions and a subtraction, so that gives us 1, 2, 3, 4 terms. So we're going to do 4 multiplications. Start off with 4 times 6, that's 24. 4 times 2x, multiplied by the coefficient and keep the variable. 4 times 2 is 8, and then keep the x. The variable part does not change if we multiply by a number. Now we're going to do 4 times 5, that's 20, and the variable is y. Now keep the sign. You have to keep these signs. The first one's addition, addition. This one is subtraction. 4 times 3 is 12, and keep the z. Notice when I do this, I remove the parentheses. Make sure when you distribute, you remove the parentheses. Up till now, we've been distributing positive numbers, and the signs do not change when you do that. The situation is very different when you distribute a negative number. So we'll see what's going to happen there. First example, you can distribute negative 6 into 2x minus 3. So what we're doing now is taking a negative and multiplying by a positive. Negative times a positive is negative. So this becomes negative 12x. Now we're distributing a negative into here. So negative times a negative is positive, so that's plus 18. So notice what happened here. We went from positive to negative and negative to positive. So distributing a negative in changes the sign on every term inside the parentheses. Your turn, number 4. First one, negative 2 times x is negative 2x. Negative 2 times negative 8 is positive 16. So negative 2x plus 16. And just as a quick check, I'm going to check, make sure that I change the sign on each of these. Positive to negative, negative to positive. That's an important thing to do. I see a lot of mistakes with negatives with these. All right, now here, it may look like we are subtracting this thing, and we actually are. But you can think of this as the distribution of negative 1 as well. So negative times a negative turns this positive, so that's just 2x. And negative times a positive is negative, so that turns that into negative 1. So if you're distributing a negative into parentheses, nothing changes except the signs. These terms stay exactly the same, but we go from negative to positive, positive to negative. All right, next up, now we've got a distribution that looks like some of the things we're going to do later on in the course. We've got this quadratic equation here. We've got an x squared term, we have an x term, and then a constant term. All, when we distribute, since we're distributing just a number, all of these variable parts will remain exactly the same. Only thing that's going to change is the numbers. So 3 times 2 is 6, so we get 6 x squared minus 3x plus 30. Your turn, number 5. First one, we have 1, 2, 3, 4 different terms, so we'll do 4 multiplications. Multiplying by the coefficient, 5 times 4 gives us 20. Keeping the variable part exactly the same, xy. 5 times negative 7, negative 35, x. 5 times 2 is 10, 10y. 5 times negative 6 is negative 30. Now the next one, we're distributing a negative, so that's going to change this sign to negative. Negative 7 times 2 is negative 14. And then we keep the variable part, x, y, z. Negative times negative is a positive, so plus 21 x to the 5th. So all these properties will be essential tools in simplifying expression. Our procedure is going to be remove any grouping symbols. Once you've distributed, we are going to combine any like terms that are around, and we'll see what like terms are in just a moment. And finally, perform any leftover operations that you need to do, like simplifying fractions. So we're going to take a look at a little bit of vocabulary first. Terms versus factors. So terms are products and quotients of variables and numbers. Only products and quotients. There's no addition or subtraction on that. So in examples of terms, we've got 3 could be a term, 2x could be a term, negative x to the 5th. Notice we're only multiplying. We got a negative sign there, but that's just multiplying this by negative 1, so it's still multiplication. 6x squared. A lot of these terms will have a coefficient and a variable part. We got some that may have multiple variable parts, like x to the 3rd, y squared. We don't write the coefficient here because we have a coefficient of 1. That can be left out. 5 over z and negative 4, x to the 4th, y to the 6th. Those are all examples of terms. And we can string these together to create things like 3x squared minus 6xy plus 2. So here's an expression with three different terms. So we have two operations, we have subtraction and addition, so everything's separated by those two are terms. So you got 3x squared, you got 6xy, and 2. Now factors are different. Factors are just multiplied together. So we could have something like 3x to the 6th and negative 2y, z. Now it's essential to know what these things are because a big part of this course later on is going to be factoring. And when we factor, we break things apart into things that are multiplied together. So make sure you can tell the difference between factors and terms. So to simplify, we need to combine any like terms that exist inside an expression. So let's take a look at this list of terms and figure out which ones are like terms. Like terms are those that have the exact same variable part. The coefficient can be different, but the variable part has to be exactly the same. All the variables and all the exponents must match. So there's a collection of terms. We need to find the terms that have the exact same variable part, and those are like terms. Let's look at these two. Here we both have an xy, so you might think those are like terms. But here the exponent is on the x, and here the exponent is on the y. So they are not exactly the same, so they are not like terms. However, these do match. X squared y, x squared y. The numbers are different, that's okay. The coefficients don't matter when we're looking for like terms. The next pair would be xy here and 8xy here. Keep in mind that that coefficient is assumed to be 1, so that would be 1xy. So there's another pair of like terms, and that's it for that list. Your turn, number 6. Find the pairs of like terms in that list. So in this list, we're looking for things that are exactly the same. These are really close. You might think those are like terms, but oh, we got a slightly different exponent there. 3 here and 2 here, so they're not like terms. X squared z matches x squared z. So 9x squared z and 4x squared z are like terms. And the other one's a little trickier. Negative 2xz and 5zx. Are those like terms? Well, as we saw, one of the properties is that with multiplication, it's commutative. It does not matter which order you multiply. So the fact that we have an x and a z and an x and a z, that makes them like terms. Doesn't matter if they're in different orders. Next example, we're going to simplify an expression. 7a plus 4a. Well, there are no parentheses, so we don't have to worry about clearing those. So we can move right on to step 2. Combining like terms. These have the exact same variable parts, so they are like terms. We combine them by adding the coefficients, 7 plus 4, that's 11, and keeping the variable. Remember, never change the variable part when you're combining like terms. Think of these variables as representing objects in the real world. Let's say basketballs. If I have 7 basketballs plus 4 basketballs, I get 11 basketballs. I don't get 11 soccer balls. So you never change what you're adding. And what we're adding is the variable part. So keep the variable part exactly the same. Your turn, number 7. First one, we have like terms, both b's. 3 plus 12 is 15, so that is 15b. Part B. Now we're going to add a negative and a positive. Negative 7 plus 3, that's negative 4. So negative 4x. Now combining like terms, this can be extended to any number of terms. You can just do it all in one step if you'd like. Here we're going to go 2x minus 8x plus 5x minus 3x. So start with 2. 2 minus 8 is negative 6. Plus 5 is negative 1. Minus 3 is negative 4. So negative 4x. Actually, did I make a mistake there? Let's see. Let me do that again. 2 minus 8 is negative 6. Plus 5. No, that's right. Part B. Oh, we got a little lost there. Oh, your turn, number 8. That's where we're at. All right, these are all x terms, so they can all be combined. 4x minus 5x, that gives us negative 1x. Minus 3x is negative 4x. Plus x is negative 3x. And next one, we have matching y squared, so they're like terms. So 12 minus 4 is 8, so that is 8. Keeping the variable part the same, 8y squared. Now we're going to combine distribution with combining like terms. Example, 8x plus 3 times 2x plus 7. So always start with distribution. I want to clear the parentheses first. The reason for that is we don't know how many x's we're going to have until we distribute. So 3 times 2x gives us 6x plus 21. Now we can combine like terms. So the terms with the same variable parts are 8x and 6x. 21 is a constant, so we cannot combine that with anything else. Or we can only combine things that are exactly the same. Because, think again back to real world objects. If these represent basketballs, we can't add basketballs with a number. What's 8 basketballs plus 21? That doesn't make any sense. All right, 8x plus 6x is 14, so that's 14x plus 21. And now it's fully simplified. We have no more parentheses, and we have no like terms. These terms are different, so we cannot combine them. Your turn, number 9. Starting with distribution, distribute the 2 into here, so that gives us 7 plus 8x minus 6. And now the like terms are the constants. So we can combine 7 and negative 6. And that gives us 8x plus 1. B, we do 9x plus, distribute, and make sure anything we're not working on, just bring it down and copy it down. So we're not doing anything with the 9x or the plus, so we'll bring those down. We're just going to distribute in here. So that's 4x plus 8. Now we can combine the x terms to get 13x plus 8. Now let's look at an example with some negative signs. I have to be very careful with these. This is where I see all of the mistakes. It almost always comes down to a negative sign. So we're going to distribute the negative 1 in. Recall that when we distribute a negative 1, all it does is change the sign on these two terms. So the 4 will become negative, and the x will become positive. And then bring down the 8. Now we can combine the constants, 8 and negative 4, add those together to get 4, so we get 4 plus x, or x plus 4. Next example, we got negative 7x minus 2 times 3x minus 4. Now we're going to distribute in a negative number. So bring down the negative 7x. We're not going to do anything there. Now we're distributing negative 2 into here. Negative 2 times 3 is negative 6. So that's negative 6x. Next up, negative 2 times negative 4 is positive 8. And now we can combine these two like terms. Negative 7 minus 6 is negative 13. So that's negative 13x plus 8. Your turn, number 10. First one, distributing this negative, so that's going to turn the 2x positive. So we get 2x. Now negative times a positive is negative, so it's going to be minus 5. And then we bring down the negative 3. The negative 3 is not included in that distribution. We're only distributing into everything inside the parentheses. So the negative 3 remains unchanged on the second step. Now we'll combine the like terms, the two constants. Negative 5 minus 3 is negative 8, so we get 2x minus 8. Next one. Now we're distributing in negative 5. We're not working on the 4x, so bring that straight down. Negative 5 times x is negative 5x. Negative 5 times negative 2 is positive 10. Now we can combine the x terms. 4x minus 5x is negative 1x. We'll just write that as negative x. It means the same thing. Negative x plus 10. You can also write that as 10 minus x. Now some expressions will have more than one set of parentheses, so we're going to do a double distribution on the next one. Distributing the 3 into x minus 1, we get 3x minus 3. And over here, 4 times 5 is 20. And 4 times negative 2 is negative 8. So negative 8x. And now we've got two pairs of like terms to combine. So we'll find the 2x terms, 3x and negative 8x. 3 minus 8 is negative 5, so there's negative 5x. Now we've got the constants. Negative 3 plus 20 is 17. Negative 5x plus 17. Your turn, number 11. First distribution, 4 into x plus 1. That's 4x plus 4. Plus 2 times 4 is 8, so we got 8x here. 2 times negative 3 is negative 6. Now we have two pairs of like terms to combine. 4x plus 8x is 12x. 4, so we have positive 4 minus 6. That's negative 2. Part B, 3 times 2x. That is 6x. 3 times 4 is 12. Negative 5 times 3 is negative 15. So we got minus 15 there. And negative 5 times negative x is plus 5x. 6x plus 5x, that gives us 11x. 12 minus 15 is negative 3. 11x minus 3. Now we're going to look at a larger expression. We got a couple of distributions and some things on the end. So 5x minus 2 times 4x minus 7, or 4 minus 7x, plus 3 times 2x plus 5 minus 10. So we're not going to do anything with the 5x on the first step, so bring that down exactly as it is. Now distribute in the first set of parentheses. Negative 2 times 4 is negative 8. Negative 2 times negative 7 is positive 14. And keep the x. Next set of parentheses. 3 times 2 is 6, so plus 6x. And 3 times 5 is 15. And then once we're done with the distribution, bring down the negative 10. Don't forget the 5x to start with, and the negative 10 on the end. Now we can combine like terms. So we actually have three different x terms: 5x, 14x, and 6x. Keep in mind that the sign precedes the term. So this one's positive, positive, and positive. Add them all together, we get 25. 25x. And now we have three different constants. We have negative 8, positive 15, and negative 10. Add all those together, negative 3. Your turn, number 12. Part A, nothing's happening with the 2x, bring that down. Now distribute, negative 3 times 1 is negative 3. Negative 3 times negative 2 is positive 6, so plus 6x. Second set of parentheses is 5 times x is 5x. 5 times positive 3, 15. And then bring down negative 12. Now we'll combine like terms. 2x plus 6x plus 5x. That's 13x. Now we'll do the constants. Negative 3 plus 15 minus 12. Well, 15 minus 3 is 12. Minus 12 is 0. So the constants all go away. They equal 0. 13x for that one. Part B. So as these expressions get larger, it becomes very important to have a very structured approach. So some students will just want to do the distribution on the next step and not bring down the other things. That leads to a lot of mistakes. On every step, bring down everything. So bring down the negative x. Now distribute. 7 times negative x is negative 7x. 7 times 2 is 14. Now distribute the second one. Negative 5 times 3x is negative 15x. Negative 5 times 2 is negative 10. All right, so that completes the second distribution. Now take the stuff on the end, bring it down. This is a very orderly approach that leads to very few mistakes. Next up, we're going to combine like terms. You got negative x minus 7x, so this is negative 1 minus 7. That's negative 8. Negative 8 minus 15 is negative 23. So we have negative 23x. Now do the constants. 14 minus 10 is 4, plus 5 is 9. Negative 23x plus 9. Now we're going to look at some expressions with what's known as nested parentheses. And these are parentheses within parentheses. And they can get a little confusing to see all those parentheses, but we're going to use an approach that simplifies it greatly. Now, usually when you have nested parentheses, the inner parentheses will be the regular parentheses, and the outer parentheses will be brackets. That's just so you can tell them apart, but they act exactly the same. First example. All right, so here's the outer parenthesis. We got 5x plus 3 times 2x minus 4. So when working with nested parentheses, always start with the innermost parentheses and remove those first. Once we remove those, then we're just down to one set of parentheses, and it'll look like just the other problem. So I'm only going to work on this thing here, 3 times 2x minus 4. Everything else, bring it down so that it looks exactly the same. And when you're working on these, I recommend doing this first. This keeps things straight. We're not going to do anything with this part. Just bring it all down. So that's the part. These are all the parts that don't change. Now we'll work on the parts that will change. The distribution. 3 times 2x is 6x. 3 times -4 is -12. Now what a lot of students like to do here is just distribute in. That's going to be more work, so I recommend simplifying first. Because if you distribute now, you have to do 3 multiplications. And then you're going to have to combine like terms anyway. Might as well combine like terms first, then you only have to do 2 multiplications in this case. So do -3, combine the like terms, 5x plus 6x, that's 11x. Bring down the 12. Now we'll distribute in. -3 times 11 is -33x. -3 times -12 is +36. So -33x plus 36. Your turn, number 13. So we'll start with the inner parentheses. I'm going to bring everything else down. No changes here. Only thing that's going to change is the distribution. 2 times 5 is 10, so plus 10. 2 times -3 is -6. Now we can combine like terms. 8x minus 6x is 2x. So we get 2x there, plus 10. Now we'll distribute in the 4. So 4 times 2x is 8x. 4 times 10 is 40. 8x plus 40. Now the next expression is a little more complex. So we've got things outside the nested parentheses. We're going to start with an 8x on the outside plus 2 times 4x plus 5 times -2x plus 1. So now we have one more thing to bring down on the first step. I'm not going to do anything here. Don't change anything here. Change nothing here. Only thing we're going to change is that distribution. So this is a great first step here. Just bring down everything you're not going to change, and then finally work on the thing that you do change. 5 times -2 is -10 with x, and 5 times 1 is 5, so plus 5. All right, I'm not going to do anything with the 8x yet, because we still need to distribute it. So I'm going to leave that. And now we can to distribute. Now let's combine like terms first. 4x minus 10x is -6x, and 5. So now it's fully simplified inside the parentheses. Now we can distribute. So bring down the 8x. 2 times -6 is -12. 2 times 5 is 10. So we get 8x minus 12x plus 10. Now we can combine these like terms. 8x minus 12x is -4x. And bring down the 10. So we get -4x plus 10. Your turn, number 14. So first step, not going to do anything with the -7x, or the 4, or this part. Just going to distribute over here. All right, so there's all the stuff that's not going to change. Now distribute. 4 times 2x is 8x. 4 times -3 is -12. All right, now we'll simplify inside the parentheses. So I'm not changing any of this. -1 plus 8 is 7, so that's 7x minus 12. Now we can distribute. So negative 7x, we distribute it in here, so plus 28x. And then 4 times negative 12 is negative 48. And we've got some like terms to combine here. Negative 7 plus 28 is 21. So 21x minus 48. All right, that is it for today. This is one of the most important skills in algebra because we're always trying to simplify things. I mean, why work with a more complex expression when you can simplify it down and work with a simpler one? So go practice.